Eutrophication is a huge phrase for a significant problem in the country's estuaries. Eutrophication, which happens when the environment gets enriched with nutrients, increases the quantity of plant and algae development in estuaries and coastal waterways. It causes harmful algal blooms, dead zones, and fish deaths. Excess nutrients cause algal blooms and low oxygen waters, which can kill fish and seagrass, while also reducing important fish habitats. Much of these estuaries also sustain bivalve mollusk populations, such as oysters, clams, and scallops, which filter feed and naturally decrease nutrients. Starting with an overpopulation of algae and plants, eutrophication sets off a chain reaction in the environment. When the extra algae and plant debris decomposes, enormous volumes of carbon dioxide are released. This causes ocean acidification, which lowers the pH of salt water. Acidification inhibits fish and shellfish development and can hinder bivalve mollusks from forming shells. As a result, commercial and recreational fishery capture less, resulting in smaller harvests and more costly seafood. The availability of nutrients, such as nitrogen and phosphorus, in an environment inhibits plant development. The growth of algae, plankton, and other basic plant life is a favored overgrowth of more complicated plant life when water bodies are too loaded with these nutrients. Eutrophication may be classified into two forms depending on the root cause. First is anthropogenic eutrophication. Human activity causes anthropogenic eutrophication. Humans provide nutrients in the form of fertilizers to agricultural fields, golf courses, and lawns, among other places. Rains wash these fertilizers away, and they eventually end up in bodies of water like lakes and rivers. When fertilizers are added to an aquatic ecosystem, they provide abundant nutrients to algae and plankton, causing eutrophication of the water body. The soil erodes more easily as a result, resulting in greater dirt deposits in bodies of water. Eutrophication and serious damage to the ecology in and around the water can result from phosphorus-rich soil. When sewage pipelines and industrial wastes are discharged into bodies of water, the nutrients in the sewage and other pollutants accelerate eutrophication. The second classification identified as natural eutrophication. It is the overabundance of nutrients in water bodies as a result of natural processes. In a flood, nutrients from the land, for example, might be carried away and deposited in a lake or river. These bodies of water become too supplied with nutrients, allowing algae and other basic plant life to flourish. When compared to artificial eutrophication, the natural eutrophication process is substantially slower. This process is also influenced by the temperature of the surrounding environment. Temperature changes brought on by global warming may even complement it. The negative impacts of eutrophication on aquatic bodies include a decline in biodiversity, a rise in water toxicity, and a shift in species dominance. The other notable negative effects are as follows. Phytoplanktons grow much faster in such situations. These phytoplankton species are toxic and are inedible. Gelatinous zooplankton blooms fast in these waters. Increased biomass of epiphytic and benthic algae can be observed in eutrophic waters. Significant changes arise in the species composition of macrophytes and the biomass. The water loses its transparency and develops a bad smell and color. The treatment of this water becomes difficult. Depletion of dissolved oxygen in the water body. Frequent fish kill incidents occur, and many desirable fish species are removed from the water body. The populations of shellfish and harvestable fish are lowered. The aesthetic value of the water body diminishes significantly. In addition, an adverse effect may include algal blooms in the water body. It can prevent sunlight from reaching the deeper depths. Many plants and animals may face extinction as a result of this. The local biosphere suffers from the loss of oxygen levels in the water body caused by this event. There are ways to reduce eutrophication, such as reducing the nutrient source, example given by phosphate stripping at sewage treatment works, reducing fertilizer inputs, introducing buffer strips of vegetation adjacent to water bodies to trap eroding soil particles, reducing the current availability of nutrients in the system, example given by removing plant material, removing enriched sediments, chemical treatment of water. Stopping the direct discharge of sewage into rivers can also help to minimize the nutrient load caused by sewage disposal. The simplest method to prevent extra phosphates from entering rivers is to prevent the detergent from entering the stream in the first place. What should we do? By avoiding their use altogether. There are several phosphate-free and nutrient-free products on the market that function just as well as traditional ones. Eutrophication of water bodies has a significant influence on human health, including gastrointestinal and dermatological problems, as well as conjunctivitis. The increase of the anthropogenic load leads to the increase of the eutrophication level and, consequently, the increase in morbidity. This is a wake-up call for us to make a difference in our lifestyles, as nature is not the only one being affected with the consequences of our actions, but also with us humans and other living organisms. There should be urgency in addressing such problems as it may snowball into irreversible effects, which we may regret in the end. We should work on little by little ways on how we can reduce and diminish acts that can severely damage our home. It relies with us, the future of our home, if there will be a so-called future.